Welcome to the third video in Gamer to Game Developer Series 1. In this video we'll implement a basic projectile which we'll call our blaster. Now the objectives for the video is to set up this basic projectile, turn it into a prefab, then we'll write a script for the projectile and we'll call that script the blaster script. It is what will cause the projectile to propel forwards and also carry out hit detection for that projectile. Then we'll write another script and we'll attach it to the player. That script will allow the player to fire the projectile in the first place, and we'll call that fire blaster. And then finally we'll set up a really basic particle system, so for the projectile's explosion, to make it look like it's hit something. So I'll explain a bit about how this projectile works. So first off, when the player presses their fire button, which would most likely be the left mouse button, the blaster projectile will get instantiated in front of the player's camera head, and it'll be in the same orientation as the camera head. So if the player is looking downwards, then the blaster projectile will also be instantiated so that it's facing forwards and downwards. And that's all carried out by the fire blaster script on the player. Now the blaster itself, it has its own script called blaster script, and this script will cause the projectile to start propelling forwards. So I'll just move on to the next slide. Now the blaster projectile, while it's being propelled, the blaster script causes an invisible ray to be cast in front of it. We can determine the range of that ray as well, but the ray is looking for a collider that it'll recognize. So in this case, we're going to set up a tag called obstruction and assign it to the floor, the plane of the level. And when the ray touches that collider, it'll realize, oh, this belongs to a game object that has the tag obstruction. So that means I've hit something. So disable myself. So this is all being carried out in the blaster script. So the blaster will disable itself and it'll just disappear. And after a set duration, the blaster will then destroy itself and remove itself from the game. So let's go on into actually making that blaster projectile. For our blaster, I'll use a capsule. So I'll go over to Game Object, Create Other, Capsule. It's just a big white capsule that gets put there. Then I'll reset its position, and I'll change its scale, make it smaller. I'll change the X scale to 0.02, Y to 0.1, Z to 0.02. So there, it's been resized. We can zoom in on it and see that it looks like a projectile now. Half in the floor though. And let's create a new material. And I'll call it Blaster. And this material, I'm going to give it the shader Particles Additive. I've just found that this shader gives the appearance that I'm after. But for it, we're going to need to make a really simple texture. I'm just going to make a full green texture and apply it. And for now, I'll just quickly pick the tint color, which will be just a full pure green. So I'll set B down to 0, G, the green to 255, and accept that. So for the texture, open up the GIMP. So once you have GIMP open, just go over to File, New, and I'll make the new image size just 256 by 256 and OK. I'll change the forecolor. I'll select the bucket tool. I'll change the forecolor to pure green. So I'll set R here to 0. So it's just 255 in the green and hit OK. Then using the bucket tool, I'll just fill that texture, finish. And I'll simply save it. So save as, and no, I want it in my documents. I'll browse for other folders. I'll move over to Game Developer. And I'll create a new folder. I'll call it Textures. And this texture, I'll just simply call it Blaster. And for the extension, I'll be using .png throughout this video. Later on, most of our textures will have some amount of transparency in them. And to support transparency, you'd use a PNG. So I'll just hit save now. Yes, everything's fine, just save. Okay, I can just minimize the GIMP. And I don't see it here, so that means I've saved it to the wrong folder. So if I just go up a level, so I'll go Show in Explorer. That'll open up the folder in Windows. I'll go up a level, and yes, I did save it in the wrong folder. I wanted it to be inside the Assets folder, so simply just drag Textures into Assets. And there's our Blaster texture. And it will appear here now, so there we have it in our project panel, our Blaster texture. So go back to the Blaster material and assign the new texture to it. I can just drag it in. I could have also clicked select and selected it from the list. So our material is set up now, and it's time to apply it to the capsule. So going over to the capsule's material, I'll change it from default diffuse to Blaster. If I click away, I can see that it has been applied. Our Blaster projectile does have a green color to it. And because our level is so bright, well, the floor is so bright, that's why it's actually hard to see. But we'll be changing that shortly anyway. To make that Blaster look a bit more interesting, I'll add a point light to it. So we'd go to Component, Rendering, Light. And it's been added in the inspector. And it's at the moment a point light. And I'll change the color. I'll make it full green as well. So I can just set R to 0, B to 0, the blue. And we have a green light. And I'll change the range of that light. So instead of a massive 10, I'll bring it right down to 1. And I'll reduce the intensity from 1 to 0.6. And I'll turn on Draw Halo. So let me just move out a bit actually. And maybe I should move the player out of the way. So let's just move that player a bit. Or better yet, just move it back. So when we spawn, we'll be able to see it in front of us. And coming back to the capsule itself. Now it's very faint, but there is actually a halo around the capsule. When we change the floor color, that'll be much more apparent. And I'll do that right now. I'll just create a new material. And I'll call it Floor. I'll leave it as a diffuse, but I'll change the color to a light gray. Or a medium gray. Anyway, let's try that out. So I go to the plane and simply apply the floor material. I can just drag it on. And I've applied it, but it looks like I haven't picked a dark enough color. So I'll just bring that down a bit more. Yeah, that's about it. So that looks much better. And I can see our capsule much better as well. So maybe I should just lift that up too. Yes, now it's much more obvious what we're looking at. So you can see that the projectile has its own light. Now I'll actually run the game, and we can just go up to it and have a look at what it looks like. So we can see, yes, it is very clear. Now you'll notice I can't walk through it. And for the projectile, I will actually turn its collider. I'll stop playing. I'll turn its collider. I won't actually turn the collider off. What I'll do is I'll use isTrigger. Now this is actually for using with trigger functions, but I'm just going to turn it on because by turning it on we can actually, the collider can pass through other colliders and it's convenient for us. And probably the main reason why I'm not actually just turning the collider itself off is because when we have rockets later on, we can actually destroy a rocket in midair using a projectile. But the chance of doing that is quite low, but either way it's fine. Yes, so now we can actually walk through it, and that's good. That's what we want. We also want that when the capsule, the projectile, it disables itself, we want it to still just pass through the floor. We don't want it bouncing along on the floor, just eating up processing power for nothing. So I'll just stop playing that. And we're ready to make a prefab for that blaster projectile. So I'll create a new prefab. Name it blaster. And drop our capsule into it. And I'll just delete the original one. And drag this one into it. Well, we've completed our first step. So the next one is to actually make the blaster script. Okay, let's create our blaster script now. So create C# script in our scripts folder, and we'll call it blaster script. And open it up in MonoDevelop. It's taken me to the camera script, and in the other tab is our new blaster script. So we'll just start typing out some quick code. We'll add comments later and flush out the script in a bit. Let's add the first variable. So private transform, the type of this variable is transform. My transform, that's going to be the name of this variable. And our second one is going to be of the type float, private float, projectile speed, and equal to 0.1 f. For floats, you always need to add the f if you're putting in decimals. In the start function, I'll say my transform. I'll assign to my transform, transform. Oops. What I'm saying here is assign to my transform the transform of whatever this script is attached to. So this script is going to be attached to the blaster itself. So I'm saying that my transform is the transform of that blaster. So it's just a quick reference to the transform of the blaster itself. So in update, and by the way, there is a big difference between the small t transform here and the big T, the capital and the one in green. That's the class, and that's pretty much just the local reference. Well, that's just how I think of it anyway. For the update function, we'll simply say my transform dot translate. So we're going to make this transform move over time. So at the bottom, translate, bracket, vector 3, so the direction that we're going to move it in. So it's vector 3 dot up, and times by the projectile speed times by time dot delta time. So what I'm saying here is make it move in the up direction and at the speed projectile speed, and I'm saying times time dot delta time so that it's smoothed out. So different computers will be running at different frames per second. If we didn't have this statement time dot delta time, then for some players their projectile would travel faster, and for others it would be slower. But by using this simple small statement, we're going to make everyone's fly at the same speed. And then I'll just close the bracket off, and that's it. And I'll save the script, and we can actually attach it to our blaster and run the game and see what happens. So head back to Unity. Now in Unity, I should probably say why I've picked vector3.up. So if I click on the blaster, now it's logical that when you fire a blaster, this projectile, you'd expect the pointy end to be traveling towards your opponent. And in the way this prefab is, the up just happens to be that pointy end, so the y-axis. That's why we've said translate the projectile in vector3.up. So when we create the fire blaster script later, we're going to actually make the projectile be rotated when it instantiates, so it'll be flying horizontally away from the player. But I'll explain that later when we get to it. So now let's just attach that blaster script to the blaster. So component, scripts, blaster script. Yes, add the component. And there we have it, it's added right here. And I'll just save that. I'll save the prefab, I'll just hit apply. Let's run the game and see what happens. Okay, you can see that the capsule is moving up, the projectile, is moving up very slowly because I chose a speed of 0.1 f. You can see that it's moving in the up direction. So if I just go zoom back on that capsule. So pretty much that's what is happening. It's just being translated in the direction of vector3.up at a speed of 0.1, and we've used time.time to smooth it out. So I'll stop playing. And before moving on to finish off the script, we haven't added any hit detection to our script, so that's what we need to add. But for hit detection to work, it needs a name to recognize. So we're going to add a tag. So just click on the plane. You'll notice with game objects they have something called tag here. And at the moment it says untagged, and there are a couple of default tags available. We'll leave the blaster untagged. Head over to the plane since that's our floor of the level. Now I'm going to change that tag. I'll change it from untagged. I'll say add tag. So I'll click on that. I'll click on this to expand the tags. Element 0. So this is going to be our first tag. And I'll call that tag floor. Okay. And when we added it, it's automatically increased the size to 2, so we can add another tag later on. But now let's head back to the plane. So we've added a new tag in the tag manager. Go back to the plane. Click on the tag. And there we have our new tag, floor. So now when our projectile is flying along, we're going to add some more code to make it fire an invisible ray, to make it cast a ray in front of itself. And when that ray touches the plane's collider, we'll make it check what the tag of what the collider belongs to, so what the tag is. And if it happens to be floor, we'll make that projectile disable itself. So let's edit the blaster script again. Let's add some more code to it. So head back over to MonoDevelop. And now I'll start putting in comments properly and write the script up properly. So in our summary, I'll say this script is attached to the blaster projectile and it governs the behavior of the projectile. And I'll add once again my variable start. So I'll just go over to the camera script. I'll just copy that variable start line and paste it in. And I'll do that again for variables end. Put it underneath. And I'll give this just a small comment. So I'll just call it, I'll say that this is a quick reference, which is what it is. I guess it's pretty obvious what this one is. But anyhow, the projectile's flight speed. Then we'll add some more new variables. So we're going to add in a bool, a true or false variable. So the comment for this one is prevent the projectile. Well, this is the purpose of this variable that I'm going to add, from causing, I'll just add another 2 forward slashes, from causing further harm once it has hit something. And I'll call it private. The type is a bool. Expended is equal to false. So when our projectile disables itself, we'll also set this bool to true, so it'll have expended itself, and it'll no longer to be able to carry out any more hit detection. So we'll set up that code soon enough. And then the next variable is going to be used for a ray that we're going to be casting in front of the projectile. So array projected in front of the player. Front of the player? No, it's not in front of the player. It's in front of the projectile, sorry. In front of the projectile to see if it will hit a recognizable collider. And that is private. The type is Raycast hit. And I'll just simply call it hit. And the next one, so the range of that very ray. And I'll say private float range. And I'll set it to equal 1.5. And I put the F. So the ray will have a range of 1.5 units. So it'll extend out 1.5 units in front of the blaster projectile. Oh, and while I'm at it, I probably should increase that speed. So I'll set the speed to 10. And since there's no decimal point, we don't actually need the F there. And now I'm ready to add more code to the update function. I'll just save what I've done so far. So now in update, I'll give it the comment, translate the projectile in the up direction. So the pointed end, of the projectile. And then we're going to add some more code down here. I'll just scroll on. We just add a lot more spaces. And just simply add more code. And here, I'll write a new comment. So if the ray hits something, then execute this code. So now we'll have our first if statement. So if, then use a bracket, physics dot raycast. So from my transform dot position, so cast this ray starting from the projectile's position in the direction of my transform dot up, so in the up direction, out hit, so we want to get feedback when it hits something, and for a distance of range, and close the bracket. And I'll put here 2 ampersands, so that means and also only run this if expended is false. So note the 2 equal signs. A single equal sign means that we're assigning something to that, but 2 means that is it that, or compare, does it compare, are they the same? So it's equal to false. And I'll put a closing bracket, and that closes the if statement. Now the block of code for the if statement, it should be within parentheses, so put an opening one and a closing one. And then inside it, we'll write our code. So if the collider has the tag of floor, then we'll execute the following code. So if, we'll use another if statement. Remember we had that out hit. So now let's check what is hit. What is this thing that's been hit? So if hit dot transform, so if the object that was hit, its transform, and within the transform there's another property called tag, the very tag that we assign to the floor. So if the transform, if whatever was hit, that transform of whatever was hit, its tag, if it's the same as floor, if that's what it is, and you have to remember what you call the tag, so you could just copy paste it again, but this ours is simple, so I can just type it in, I remember. I'll just close the if statement. So if it is floor, then let's run the following code. So once again, an opening parenthesis and a closing one. Then the first thing, I'll set the bool expended. I'll set it to true. So you remember here I was saying check that it's, one of the checks is if it hits something and expended is equal to false. Now that it has hit something that it recognizes, I've said expended is equal to true. So when it runs this update function again, it'll still translate the projectile, so it'll keep flying, but the raycast will not happen this time because it knows that it's been already consumed. So not only that, I'll also make it go invisible. Let me just scroll down. So make the projectile become invisible. And to do that, we just simply do my transform dot render dot enabled is false. So equal to false. Assign false. And if you look here in the mesh render, all we're going to do is simply, when we say enabled is equal to false, we'll just uncheck this. So you can see when I uncheck the planes render, it just became invisible. Likewise, let's go to the blaster. And if I click its mesh render, uncheck it, it'll become disabled and it'll be invisible. So that's simply what we're doing. So then back, typing up our script. Let's add another little space there. And not only that, let's turn off that light as well. So since we're making it invisible, we should turn off that light component as well. So I'll just add in the comment, turn off the light. 2 Fs. Turn off the light. So the halo will also disappear by doing that. So my transform, very simply, light, because this is one of the things that could be attached to a transform, dot enabled is equal to false. Now it doesn't actually know that there's a light attached to the transform until it executes that code. So even if you hadn't attached the light, you could have still written this line of code. It's just simply a property available to the transform. Okay, so we should save our script now. And we can go back to Unity and see how it runs. Alright, so we're back in Unity. And what I'll do is... let's see, how should I do this? Let's zoom out. Let's move the projectile up, say, 40. So it's a fair way up. And let's rotate it so it's facing downwards now. So let's just flip it around 180. Let me just go have a look at that. Yes, it is like that. Actually, no, let's make it 20. But then again, it is pretty fast. What I'm going to do is just see how it looks when it disables itself, when we run the game. And let's just run it, see what happens. Yeah, that's pretty fast. Let's just try that again. What just happened? Alright, there, I paused it. Now let's just zoom in on it. Okay, so it is still active. It's still well above the ground. It's at 33 units above. It'll disable itself when it gets to within, well, gets to 1.5, because that's when its invisible ray will hit the ground. And then it'll disable. And how long will it take to get there? Well, get there pretty fast because we set the speed to 10. So let's just unpause it and hit pause again. And how about we just keep on? Yes, it's disabled itself now. You can see the mesh render. You can look at the distance. It's -2. I'll just zoom in on it. And yes, it's invisible. It's gone underneath the floor now. So it is working. Our blaster is actually making itself invisible. It's turning the light off as well. But if we leave it as it is, it'll fly on forever and ever and ever. So we need to make it destroy itself. So let's just stop playing. And we'll add a bit more code. And yeah, I just feel like changing that back to what it was. So I'll simply set that to 0. And I'll just put that down to 10. Oh, probably didn't need to do that. Anyhow, head back over to the script. And what we're going to add now is a coroutine to our script. So this is a piece of code that'll execute after a certain amount of time. So the first thing to do is to add a new variable to our blaster script. So I'll call this one the comment, the lifespan of the projectile. So private float expire time is what I'll call it, is equal to 5. So after 5 seconds, we're going to make our projectile last 5 seconds. So even if it doesn't hit something, after 5 seconds, the projectile will just destroy itself. So if someone shoots something up into the sky, it would fly on forever and ever and ever if we didn't have any sort of way to make it destroy itself. So we'll just simply put a time limit on that projectile. Now we'll create a different sort of a function. We'll call it, it is called an IEnumerator. This is our coroutine. So IEnumerator. There, the last one. And I'll name it destroy myself after some time. And put an opening closing bracket. And then its code will be within a parentheses. So give it an opening and closing parenthesis. and type the following comment. So wait for the timer to count up to the expire time, and then destroy the projectile. Now this code would write, the first one is yield return new wait 4 seconds, and then brackets expire time, so in opening and closing brackets. So what it's going to do is, this bit of code is simply saying that make this coroutine hang on to its piece of code until this amount of time has elapsed. When that amount of time has finished, then carry out the instruction in the next line after it. So the next one is destroy my transform dot game object. So the game object is at a higher level than the transform, and everything that we're dealing with in Unity, like the capsule itself, the player, the projectile, the floor, these are all called game objects. And to understand better, I'd recommend that you do Google search. Do a Google search like Unity, what is game object, and you'll get an explanation. Well, far better than whatever I could explain. And that is it for our IEnumerator, for our coroutine. Now, back in the start function, this is where we'll initialize our coroutine. So as soon as this blaster is instantiated and this code runs for the very first time, we'll make this coroutine start then. And so once the 5 seconds is over, it'll then just execute the destroy. If we put it, for example, if we had put it in update, then every frame it's starting this again, but there's no reason for that. So in start, I'll simply say, well, first of all, I'll put the comment. So as soon as the projectile is created, start a countdown to destroy it. And then to use that coroutine, we say start coroutine brackets the name of that coroutine. So destroy myself, you can see it there, destroy myself after some time. And then just put an opening and close that bracket, and then another closing bracket and a semicolon to finish that line. And we're ready to save this script. So just save it and head back into Unity. So now we're going to run the game and see what happens. We'll watch our blaster, watch it for 5 seconds. What does it do? So hit the play. Oops. Let's keep on, let's pause it. So maybe I should just get under it so we can see it a bit better. There we go. Yeah, that's about the right position, I think. Unpause it. Oh, okay, and that was the 5 seconds. So as you can see, it's disappeared from the hierarchy panel. Our projectile has actually destroyed itself after its 5 seconds. So I'll just stop playing that. And actually, you know what? Why not let's just watch that again. So I'll hit play. You can see it flying off over into the sky, and then it disappears. So yes, our code is working. So what should we do? Let's save this blaster projectile. So I'll hit apply to save the changes that we've made to it. And, well, I guess that finishes this step, because the next step would be to create the Fire Blaster script so that our player can fire this projectile. And as always, let's save the scene too. So I'll just hit Control S. We're making excellent progress, and we're on to step 3 of 5, which is to now make our Fire Blaster script, which will attach to the player. Before writing our Fire Blaster script, let's just specify which button we'll be using to actually fire the blaster. So we can go to Edit, Project Settings, Input, and just expand the axes. And you'll see here some predefined controls. Our player controller is already using the horizontal and the vertical, but the one that I want to edit is Fire 1, so I'll just expand that, and I'm just going to change its name to Fire Weapon. So I'll just do that now. So Fire Weapon. And no, I don't want this other, see here it's got a positive button of left control. I'll just delete that. And I'll set the positive button to mouse 0, which is the left mouse button. Mouse 0. And if the key was recognized, you'll see that this will stay. If it was something not recognized, it'll just delete and go blank. I mean, for example, here, let's say capital E, it won't recognize that, it'll just go blank. But if I said E, it'll understand that I'm talking about the key E. So I'll actually just put that back to mouse 0. And I'll get rid of the alternate button. The reason why I got rid of left control is because we'll implement crouching, well, it's actually fake crouching, later on in the series. And when we get to that, I'll explain that. Okay, so we have our fire weapon set up. Okay, that input is done. So now we can actually create our script and name it Fire Blaster. And then open it up in MonoDevelop. And let's straight away start typing out stuff. So in our summary, this script is attached to the player and allows them to fire the projectile. And for our variables, I'll once again just copy the variable start. Yes, I'll be doing it for every single script. And the variables end. And within it, I'll start typing out our variables. Well, the comment for it first. So the blaster projectile is attached to this in the inspector. That's how we're going to instantiate. So let me just write the code. It'll make a bit more sense. So public game object blaster. And what this is going to do, we've just created a public variable, a type of game object called blaster. And what it's going to do is on our player, when we attach this Fire Blaster script to the player, it'll create an empty slot where we can drop in our blaster game object prefab. So when we write the instantiate code, it'll instantiate that very blaster which has been attached to the player. So when we get to that, it'll make more sense. It really is very clever. Okay, then some quick references. Some cached variables. Private transform, my transform, and private transform camera head transform. And then I'll make another variable. So this one is the position at which the projectile should be instantiated. So at which the projectile should be instantiated. And that's going to be private vector3. And the name of this vector3 is launch position is a new vector3, and put the brackets and a semicolon. So that's how you declare a new vector3. And in start, so we're finished with the variables. Let's assign those references. So my transform is transform, and camera head transform, just like we did earlier for our camera script. We're going to say my transform dot find, not just find, but find child. And what is that child? Camera head. And that'll be it for the start function. Let's also type into the update now. Well, let me just put some spaces. So an if statement, if input dot get button. Remember we called it fire weapon. So we type the name of that button. The name is fire weapon, as we had defined it, and close the if statement. So if the player clicks the button, the fire weapon button, which happens to be left mouse click, then carry out the following script in these parentheses. So launch position, the position from which the position at which the blaster projectile should be instantiated at, set that position to equal camera head transform dot transform point. Now that position 0, 0, 0.2f, and close the brackets. So what I'm saying here is that the launch position of that projectile, it should sit just in front. That's why I'm using transform point. It should be instantiated just in front of the camera head transform. So I'm saying 0.2f in the z-axis. So let's just go back to Unity for a moment, and I'll go to the player. Let me just zoom in on the player, move up, and expand it. I'll just click that camera head. So the transform point, what that is going to do, we're saying 0.2f in z, so it's going to place, when it instantiates the projectile, it's going to place it just in front of the camera head at some position, let's say like this is 0.2f away in the z direction, and that projectile will get instantiated like somewhere there. So I'll probably just put a comment there. The launch position of the projectile will be just in front of the camera head. Okay, and then let's continue. So now we'll instantiate that. So we'll say, I'll write in the comments, create the blaster projectile at the launch position and tilt its angle so that it's horizontal. Oops, let me just spell that correctly. So that it's horizontal at an angle of, well, using the angle Euler angles dot x plus 90. Then let's just type out that code. So instantiate, which we see right there, brackets blaster, so the game object that we want to instantiate, so the one that we've just said here, blaster. The position we want to instantiate it at, so we can see here it's expecting a vector 3 position. So I'll type there, launch position. Now it needs to know what angle what should its orientation be. So we're going to use quaternion dot Euler. And so we'll specify each angle individually in degrees. That's why we've used quaternion dot Euler. So camera head transform dot Euler angles dot x plus 90. So I'm just setting the x angle now. So the x angle is going to be the camera head transform. I'm saying dot Euler angles, so let's use degrees and add on 90 degrees to whatever that happens to be. So by doing that, our projectile will be tilted downwards, so that way it'll be flying horizontal. So when it gets instantiated, it'll fly away from the player in an expected direction. So to understand that better, so once I've typed it out, do change the figures and see what happens, and you'll understand what the code is doing. I'll move that down to the next line now. And I'll say, so for the next angle, it's just simply my transform dot Euler angles dot y. And for the z angle, just put 0. And close off the brackets, and then again, and the semicolon. Right, so that's as much as I'll type out just for now. We can actually run the script. So let's save it. Head back to Unity. Oh, and if you don't save it, then like if you didn't save the script and then you went back to Unity, it wouldn't recognize any of the changes. So that's why we have to save it. So head back to Unity. And let's attach it to our player. So select the player, go to Component, Scripts, Fire Blaster. Yes, add the component. Now scroll down. Now you'll see here Blaster. That was that public game object that we made. And you can see here none, no game object has been assigned to it. So we can click on it to assign it here. And there's our prefab, the Blaster prefab. So I'll just add it. And we could also just drag it from here and just drop it in there. So now that it's there, when we instantiate, it has something to instantiate, the blaster. So I'll save the game. Well, the scene more like. It's not really a game yet. And let's run it. See what happens. Okay. And I'll just zoom out of the player. Alright, so you can see, can you see what's happening? So yes, it is working. Let me zoom out in the scene view a lot more. And what's happening is that a whole heap are getting instantiated in rapid succession because we used input.getButton. But there is another option which is input.getButtonDown. But that would only work each time the player clicks, and we wouldn't want that. We want an automatic weapon. So we need to add a bit more code using time.time to regulate our rate of fire. So let's go back to our script and do that. The truth is I actually quite enjoy being able to fire so many projectiles, but yeah, I guess we do have to put some sort of a cap on it. Alright, so head back to the script. And I'll just stop playing it back there, and I'll come to the script now. And we need to add it. We need to add 2 new variables. Yes, 2 new variables. So what do they do? It's used to control the rate of fire. And these variables are private float, fire rate equal to 0.2f, and the other one, private float next fire. And within our script, go to the update function, and in this if statement, so if input.getButton down, just start adding a bit more code here. Put in 2 ampersands, so both these conditions need to be met, and time.time is greater than next fire. And within the block of code, add in next fire is equal to time.time plus fire rate. So now let's see if I can explain that properly. So what we're saying is, don't execute this if statement even if the player is pressing their fire button. Check that the time has become greater than this variable next fire, which is a float. And if it wasn't, then we would fire a blaster projectile, and next fire would equal to whatever the time is right now. So I'll imagine, say, we've been running the game for 30 seconds, so the time is 30 seconds, plus our fire rate, so that means it would be 30.2 seconds. So if the player is still holding down the get button, now every second we may have 30 or more frames, so this bit of code will have been executed so many times in a single second. So because we have 30.2, when it looks again, it'll see that time.time, so the time.time, maybe it's only 30.05 seconds. It isn't greater than next fire, which is 30.2 seconds, as we had just used in the example. So because of that, this bit of code will not run, and another blaster projectile won't get instantiated. So it's a nice simple way to control our rate of fire. So I'll just save that and go back to Unity. And let's play the game and see the effect. And yes, you can see immediately that it has an effect. Most definitely. Oh yeah, and we can shoot at the floor, by the way, now, and see our projectile disappearing and disabling itself. If we shoot at the cube, it won't get disabled, it'll just fly through, because we haven't given the cube the tag of floor, so it isn't even recognized by our blaster projectile. Yeah, but that is feeling much, well, I guess that feels sane now. So I'll just stop playing. And before moving on to the next step, let's just delete this freestanding blaster. We don't need it around anymore. And I do believe I did save the latest changes to it. Yes, I'm pretty sure that I did, because that's what we've been instantiating. So I'll just delete it from the hierarchy panel. So delete, and I'll save our game. And we can move on to the next step, which is to set up a particle system. I'll just run it again. As you notice, as we shoot at the floor, it doesn't really make much sense to, I mean, imagine if you're a player, you're shooting and you shoot at the floor and suddenly your projectile's just disappeared. There's been no effect to make you understand what you've hit. So that's what we're just going to add. We're simply going to add a little particle system that'll appear at the point where the ray actually hits. So I'll stop playing. And let's move on to the next step. We're on to step 4 of 5, and we're ready to set up our blaster particle system. Okay, so let's create a new empty game object. So game object, create empty. And to this game object, we're going to add 3 particle components. So component particles, we'll add an ellipsoid particle emitter. Then we'll go back, particles, add a particle animator, and then once again, particles, a particle renderer. And we can see that our particle system is rendering now, and it's just a bunch of pink squares because no material has been applied yet. I'll just reset its position. Okay. And I'll zoom in on it a bit. Okay. Now to give it a material, we go to the renderer. So under particle renderer, in materials, currently you can see that no material is applied. So go ahead and apply, let's see, there we go, default particle. So select the default particle material and you can see the appearance has changed immediately. So now we're going to configure our particle system so that it's nice and small and it looks like it's hitting at a location. So the settings that we'll use are, we'll change the max size of the particle to 0.3. We'll change the max energy to 0.5 and the minimum energy to 0.1. You can see that it's changing already. We'll change the minimum emission, so the number of particles, to 100. Oh, and the energy is how long it'll last for, and the size was the actual size of that particle. And the max emission is 150. So when the particle system is instantiated, it could be anywhere from 100 to 150 particles being instantiated. Then we'll set the tangent velocity, and we'll set this to, for all of them, we'll set it to 0.5. And once again, 0.5 for the Y, 0.5. So it looks sort of like it's hitting and spreading out and away from that hit point. And we'll set one shot to true. So all of the particles are instantiated at that one moment, which is what we want. And we'll just change the ellipsoid shape as well. We'll make it more compact. So we'll change the ellipsoid shape X to 0.1. We'll change Y to 0.2, so it has a bit of a, just slightly more height to it, and Z to 0.1. So let me just move this up again. So change the position of our particle system to 0.5 above the ground. It's easier to see then. And you can see that we have made it much more compact. And we should also set auto destruct. So under the particle animator, set it to true. So once it has been used up, this particle system, it just gets rid of itself. And next I'll change the color of that animation. So at the moment it's all white. So I'll leave the first one white. Then for the second one, I'll go for pure green, except I'll make it a pale green. And then for the third one, I'll use the color picker tool right there. And select that color. Then I'll open it up and just move it along a bit more, a bit darker. And then once again, I'll use the color picker tool for the next one, do the same thing, and make it a bit darker yet some more, yet again. And then finally for the last one, I'll use the color picker and make it, well, much more pure green. Let's see, how does our particle effect look? Yes, it looks better, looks kind of green. we're going to create a new texture for our particle effect. I don't quite like the soft default particle appearance. But first, let's just create a prefab, create this explosion effect, well, this particle effect, and let's make it instantiate when the projectile hits the ground. So we'll do that first, then we'll create a new texture and apply that texture instead. So we'll create a new prefab, and I'll name that prefab Blaster Explosion. And I'll drag this game object into it. Okay, that's done. It's there. And I'll simply delete the original. I'll save the scene. And we'll go back to our Blaster script and edit it so that it can instantiate the explosion. So the first thing we'll add in our variables at the top, or at the bottom, wherever. I'll just add a comment. So the explosion effect is attached to this in the inspector. And that is a public game object, Blaster Explosion. And within our update code, we'll want to instantiate that explosion effect. So let's just put it in here above the bit where we're making the projectile become invisible. I'll say instantiate an explosion effect. That's the comment I'll place. And then I'll write the code, instantiate Blaster Explosion hit.point, so the very point at which that ray hits, that's the position that it should get instantiated at. And for the rotation, I'll just simply say quaternion dot identity and close it off and end the line of code. And we can save it. It should be working now. So let's just save. Oh, well, first, of course, we have to attach that Blaster Explosion prefab. So head back to Unity, and for our blaster, since it's the one with the blaster script, you can see here that we now have Blaster Explosion. There's nothing attached. Just drag our prefab Blaster Explosion into it. Okay, and we should be ready to go. So I'll just hit play and fire away, and yes, it is getting instantiated. You can see that happening. Let me just move out here in the scene view and do that again. And we can see that our Blaster Explosion effect is most definitely appearing whenever the projectile hits the ground. Okay, but as I said before, I do want to change that texture. So that ends it for this step. We did actually implement the particle system. In our last step for this video, we'll create a new texture for our Blaster Explosion. So I'll just stop playing and move on. We're on to our last step now, which is to make that particle texture. Okay, I've opened up the GIMP again. So go to File, New, and yes, let's just make another 256 by 256 texture. Hit OK, and I'm going to add a alpha channel, make it so that we can make the texture transparency. So go to Layer, Transparency, Add Alpha Channel, and then do Edit, Clear, and remove this. So now it's actually transparent. And we'll now add our particle effect, well, what the texture will look like. So we just go to Filters, Light and Shadow, Gradient Flare, And the one I'm going to use is Distant Sun. But I don't want to overwrite the original, so just make a copy and call the copy Blaster. And then click on the Edit button so we can change it. Move over to the Glow tab and we'll change the hue rotation. So that's the color of it. We'll change it to yeah, about there, so 170. So I'll change it to 170. And I'll change the color for the rays as well. So moving the hue rotation, I'll just keep increasing it till we start getting a green color. We are now. And it's about 70. It's about 70. That's the color that I'm after. So I'll put it to 70. Go back to general. And yes, that does look about right. So I'll say OK. And this is where it'll get placed in the texture. And it's showing me that it'll place it in the middle, which is just fine. So I'll just say OK. And there we have it. And we just need to save it now. So file save as. Oh, that message just came up because remember we had saved in the textures folder and I had positioned it in the wrong place and then I dropped it into the assets folder. So that's all that was complaining about. So go into the assets folder, go into textures and change the name to Blaster. And for the extension, just change it to PNG. I could actually just type .png there and hit save. Oh wait, sorry, my mistake. I shouldn't call it Blaster. I should actually call it Blaster Explosion. Otherwise I'll be just overriding the other Blaster texture that's there. So I'll hit save. And yes, just keep all the default settings. And we can just jump over to Unity now. If we scroll down, we can see that it has been added. I know, we just see a white thing there because that's... I'm not sure how to explain it properly, but that's, I guess, the color that's being removed to get the transparent effect. The white color. And we can actually change that, and we will do that later when we're making icons. We'll change the color so we get a smooth finish on the edge. But anyway, that's besides the point. Now we need to just make a new material. So create material. And I'll name it Blaster Explosion. I'll need to change the shader. So I'll change it to Particles, Additive, Soft. So let's try that out. And I'll select the texture. Yes, my particle texture. So you can see what it looks like in the preview. And it most definitely is transparent. And the next thing that we want to do is we want to go back to our particle system. And in the renderer, change that material. So I have my Blaster Explosion material. So let's drag that in and replace the default particle. Okay. I'll just save the scene and we should be ready to test it out. So now, yes, and you can see it. To me, that looks a whole lot better. I like the appearance more. Though for everyone, it's different. I just find that it looks quite a bit sharper. And depending on the color of the floor, so if it was a darker or richer color, the explosion effect will be much more obvious. It'll be much clearer as well. But I feel that does look quite a lot better. Okay, so we have actually reached the end of video 3. And in this video, we went ahead and implemented our blaster projectile and its system. And as we proceed through this series, we will upgrade the blaster projectile. And actually from the next video, we're going to start implementing multiplayer. So we'll set up our multiplayer script and we will actually start implementing our multiplayer system. And from then, everything that we've been doing is going to change a bit. We're going to be adding a bit of new code, well, just a few lines to the scripts that we've written. So our player will be changed and our blaster projectile will change, and we'll also edit some of the, I'll just stop playing there. We'll also edit some of Unity's own scripts as well and reconfigure them for multiplayer. It'll be a simple job though. The next video will be pretty long though, as we'll implement the entire multiplayer backbone for our game. And it is probably one of the most important videos in this series. So thank you a lot for watching, and see you in the next video.